Thank you.
Good morning, everyone. It's a great pleasure, and I extend a warm welcome to our esteemed guest and delegate from Ducon Technology. We are honored to host you, sir, at Amity University. Ducon Technology has a legacy dating back to 1938. It has been pioneer in engineering and supplying customized system for emission monitoring, decarbonization, green energy, material handling, infrastructure, etc. Serving a global clientele across industries such as chemical refineries, steel, mining, infrastructure, Ducon's commitment to innovation and excellence is truly commendable. Our deliberation with Ducon Technology started during GH2 Summit held in 2024, where they showcased advanced fluid control system, which exemplified their leadership in hydrogen mobility and hydrogen storage. Building upon the foundation has been marked by the joint submission of proposal under MNRE call for proposal for establishing the Center of Excellence on Green Hydrogen, leveraging Ducon's expertise in hydrogen storage. Building upon this foundation, now we are exploring the possibility of joint research and development throughout the hydrogen life cycle. Honorable Founder President Sir Dr. Ashok K. Chauhan has launched Amity Hydrogen Mission, focusing on advancing sustainable hydrogen technology and fostering innovation in hydrogen sector to contribute to India's national green hydrogen mission. I'm sure that today's deliberation will pave a way to advance sustainable energy solution combining Ducon technological innovations and Amity's research capabilities. We look forward for the fruitful discussion today. To commence the program, I invite Dr. A.K. Singh Sir, Senior Vice President, Amity Foundation for Science, Technology, Innovation Alliances, to deliver a welcome address and present an overview on R&D ecosystem of Amity Group. So,
Good morning and namaskar to all of you. What a great day that today we have amongst us the stalwart in their field, Mr. Aron Govil, his elder brother, Mr. Alok Govil, and Mr. Banerjee. Banerjee, you are sitting here. At the outset, whenever we say Aron Govil, we get reminded of a very great character in Ramayana. Yes. And he's also sitting MP from Ghaziabad. Recently he became great. Okay, on behalf of Honorable Founder President Dr. Ashok K. Chauhan, Chancellor Dr. Atul Chauhan, all trustees, I think in absentia, Honorable VC, Dr. Silva Murthy, and whole Amity family, I take the privilege of welcoming you, and we are so grateful to you that you have spared time and you are with us this morning. And today, I think the two giants in their respective field, if we see the Amity, Dr. Ashok Chauhan, he is giant in the higher education, delivering the higher education system, not only in India, but abroad. And simultaneously, when I was going through the profile of Ducon, I found that you are second to none. So that's why I said today is a great moment, great day. In nearby state, they are deciding for 5 years the new government. And today we will also decide about what we would be doing in green hydrogen. Because today the voting is going on in Delhi to select their state government. And I think when we talk of, because we shall be mainly focusing our discussion on green hydrogen. And when we talk of green hydrogen or hydrogen, basically it is the energy. And I feel that for any technology or any development, if there is a one common denominator, that is energy. Because I think Dr. Silva Murthy sir will agree with me. I think in Leh, the main impediment was the energy, the grid electricity. Suppose you have energy and the ample energy, I think you have edge over rest of the competitors or the world. I think green energy or the hydrogen energy, which has lot of potential to address this problem. And India being at the cusp of becoming the developing country, I think this is a more of a concern to us, or it becomes cusp of becoming developed country. Sorry, I might have missed. No, okay, sorry. Cusp of becoming the developed country. I
hearing that all these years, but now we become a developed level, becoming a developed country.
yeah. I think the whole world would start saying that, because we have reached to that level or at that point. I think for us this is more important, because we need more energy. And the government of India has already announced that by 2047, we will become the carbon neutral. And in this regard, there is a big role of academia and the research if we have to take lead. And this can only be possible if we hold hand or if we shake hands with the industry, and that what is going to take place today. And I think we have a long way to go in terms of energy per capita. If I don't want to take much time, but today we use with a factor of 10, means lesser energy than US. What we consume per capita and what United States consume, it's a difference of 10x. I think we need to reduce that gap, and we have to work in all the aspect of green hydrogen cycle, right from production, from storage, from transportation, from safety, and also from the utility. And we find that your Ducon has mastered, particularly in the storage, besides other renewable energy aspects. I think we will work together, and we can only take edge if we do R&D and are able to develop something new or something better which is not existing, and that only R&D centers can do. Now, the second aspect is I have to take you through the virtual route, a virtual view of the whole MIT education group. But before that, I have another pleasant duty to perform, just to share the personalities who are with us. I think Ducon, Isha has already said about Ducon, but today we have the man, the captain of Ducon, or the founder of Ducon, who started, Mr. Aron Govil. I think many of you must have read his profile, which is available on the Google. I find that he is a unique amalgamation of a technocrat, a technical person, entrepreneur, a writer, a leader. And to my surprise, and maybe to the surprise of all of you, he had been associated with cinema, celebrity. I think we would like to know that how did it happen, and which is more fascinating, the technical aspect or the cinema.
You want me to answer that?
No. And he's okay. You want to answer?
No, I'll tell you. When I'm sitting in a flight, in an airplane, and someone's sitting next to me, and they're asking me, "Oh, yeah, who are you?" Yeah. So he said, "What do you do?" So I said, "I have an industrial business company." Okay, thank you. They go to sleep. The next time I said, "What do you?" I say, "I make films." They would never leave me alone. Then they will just keep talking. What films? Oh, Bollywood films, Hollywood films. Oh, this actor. I mean, so fascinated. That so when you answered your question.
Okay, no. You have answered, but I have taken a lesson. Next time, we all will try this.
Yeah.
Okay, thank you.
Yeah.
Now, Mr. Govil has done his bachelor's in chemical engineering. After that, he did his master's in business administration in finance. And he had the unparalleled, successful career of 4 decades in Ducon. And he's the man who started single-handedly or single person, and he has taken this company to that profile. And this company is proud to share with us that they have 30 patents in advanced technologies. And they have completed about 30,000 utility or industrial projects till date. And they have been recognized by various forums, like they come in the list of 50 minority-owned campuses and also leading Indian-owned company in USA. If I have, there were many, but if I have missed, you would excuse me. And I have already addressed that Bollywood and Hollywood, and that's great. And he is also a writer. He wrote a very effective book and which drew a lot of attention, particularly in the Amazon, The State of Politics in the USA. Sir, we would request you to just show some light or say a few words when you speak about this book, because the title is very fascinating.
Well, it's a mixed bag of things because it's just like in India, politics is, there are two sides to it. But during COVID, what happened was it was something where there was a lot of free time. Starting March 20, everything shut down. I mean, for a while at least, until we came back on online work and all that. So I was just, debating what to do. And then my wife, she's very politically active. And we used to discuss, she said, why don't you write a book? And then I said, what is important? And that's when Trump was in the first term of presidency. And we had seen how things had gone and during his term and all that. So I just decided to write, did some research for a long time and wrote about the state of affairs, that how can, the country elect someone like that, and how, it's all things that have been in the past, the morality, the sensibility, and what we consider norm is no longer the norm in the society. And how can society become like that? What causes people, half the country, to become and accept that as normality, which was never accepted?
Right.
And is not accepted by normal people. So I wanted to get behind reason and put that reason. So that's what that book is about.
I'll find this book and read it. And Mr. Govil has been honored by various agencies. In 2008, he was honored for the Excellence Award by USPAAC, which is the largest Pan-Asia American business organization. And when he was, awarded, or when he was honored, he shared the days with the chief of Pepsi Foods, Indra Nui, and one of the young, player also, those who were there. And he's also amongst the 25 most influential Indians in North America. And in 2014, he was also honored as Person of the Year. Sir, so great. We are honored to have you with us. And today we also have his elder brother, Mr. Alok Govil, who is also a technocrat, and he did his master's in chemical engineering. Now he is consultant and advising Ducon. Besides that, he is also in other businesses in IT or in formulation, or particularly the little bit which I shared with him in research. So, sir, we also welcome you. So nice to have you with us.
Because of his background he did a lot of research. He managed early on research for Revlon cosmetic company. So I felt, I asked him if he can join me also, because such an endeavor requires a lot of support and effort from our side. So I said, I want you to firsthand see everything and all that, and then hopefully going forward, get his support.
Thank you. Yeah. Now we also have with us today Mr. Devashish Banerjee. And Devashish Banerjee is also a unique amalgamation of many expertise in science. Nuclear energy, nuclear, aerospace, and energy. Nuclear, aerospace, and energy. What a deadly and a unique combination. And his expertise also spans on a big canvas, right from thermodynamic modeling, high performance computing, then radiation protection or radiation biology, then some scanning electron microscope, and he is also interested in space exploration, satellite technology, and his main goal is to bridge the gap between technical expertise and managerial capabilities to drive innovation. What a great thought. Thank you. We welcome you to MIT. Sir, now in next 10 to 15 minutes, I'll try to take you to the, MIT universe, MIT education group. We call it, it's a universe. It is not an institution, it's the universe. So though the task is very difficult to cover everything in 10 minutes, but I'll try to justify. And if I miss some slides, you would excuse me. So today you are sitting in a campus, the main campus or the primary campus of MIT Education Group. And the MIT Education Group was started by Honorable Founder President Dr. Ashok K. Chauhan, who was a leading businessman in Germany, very flourishing businessman. Then he decided to do some philanthropy, and he decided that I should go back to India and educate people. And he wanted to educate people in a different way by combining the sanskars of from their side, East, and the technology and new things of the West. He wanted to combine East and West, means best of the East and best of the West. And today I can say very proudly that he had been more than successful in his dream, because today MIT stands tall, and it's the one of the most happening place in higher education, not only in India but abroad. And I was in one of the gatherings which was attended by many senior people, and they said Dr. Ashok K. Chauhan is the most successful, and his strategy and his thinking has really worked the way MIT has grown and the way MIT is at the moment. So, sir, thank you, Founder, sir, for all this. And he's also helped or assisted by five of his able sons. The one is Dr. Atul Chauhan, who is the chancellor of this campus, and he is the product of London School of Economics. And the younger son, Dr. Asim Chauhan, who is the product of Wharton Business School, and Dr. Asim is chancellor of some campuses, means they have the campuses for which they are a chancellor, and they are also president and additional president of Ritanand Balved Education Foundation. Other sons, they also help him. And if we see, the whole family is educated, and they got education from the top institutions in the world. The youngest son is alumnus of Harvard Business School. So the education is being delivered or propelled by the educated people. That is the uniqueness of MIT Education Group. Today, we have more than 700,000 alumni all over the world, and performing and contributing in various fields. And we have around more than 250,000 students who are working or studying, 6,000 regular faculty, and equal number is visiting or adjunct faculty, 11 universities and 13 campuses in India, equal number abroad. And MIT Education Group delivers or provides education right from kindergarten to postdoctoral. So that kind of a canvas we have. And recently, MIT Education Group has launched the Harrow School, a big name in Europe, and one school is functioning in Bangalore. And it's a worth visiting place. If you happen to go to Bangalore, please visit that. Coming to the ranking, because whatsoever we do, it has to be, evaluated. And we have a legacy of rankings. In university, we rank at 32. Let me share with you, out of more than 1100 universities and institutions which participate. We stand at 32, though the number of higher education institutions is much higher in this country. And in pharmacy, 22, management and engineering, you can see, then we are ranked at, top 3% universities by the university ranking, the world university ranking. And we are the only university in Asia which has been recognized by, US regional accreditation, where, and this agency accreditates the best of the institutions like Princeton, like Stanford. And we are also first university to be reviewed by QAA. Just to show you the glimpse of various campuses in India, abroad, right from Singapore, Mauritius, London, Nairobi, and Dubai. And we have two campuses in USA. One is San Francisco and other is in New York, Long Island. The whole island belongs to MIT, where the founder president wants to establish it as the world R&D center in traditional knowledge. Now, coming to the programs which MIT Education Group or MIT offers, you see all programs right from the social sciences, management sciences, physical sciences, biological sciences, law, culture, art, we offer like biotechnology, cyber crime, neuropsychology, space science, molecular medicine and stem cells, geoinformatics, space science and technology, and even the defense technology. And the tagline of MIT is that it's a research and innovation driven university, because as I said right in the starting, that the lot of emphasis is given on the research, because that is going to be the differentiator for us to become the number one university. And it is not only the tagline, the trustees, they ensure that it is done. So all the processes and the guidelines, they are in place. I'll just share with you, because I had been a researcher. I feel that first should be the will, because if you see all the big projects which have been done in the world over, because even in America, the government decided that we want to put a man in space, and they did so. So the will of the trustees is ample, which you might have felt by now when you have visited various departments. Support of the management. When I say management, means the functionaries, vice chancellor, director, dean, registrar, they ensure that ease of doing research is there. So it is a seamless thing that the researcher is not harassed. Infrastructure, I need not to say. We have got reasonably very good, rather enviable infrastructure among the higher education private institutions. Human resource is the main thing which propel or which differentiates. And we have the unique combination of the experienced, in which category me and Dr. Silva Murthy and Neeraj Sharma belong, and the young energetic people. So combination of both, and which is working quite fine. Enabling processes, how we push it, I'll share with you, and collaboration with industry and connect. I think today's meeting is example of that. If I say enablers, we have a IPR protection cell and Directorate of Innovation and Technology Transfer. Dr. Minakshi Kanoji is sitting, she heads that. And it is DITT is a DST, Department of Science and Technology sponsored program. We have MIT Center for right from the beginning, this kind of a mindset is inculcated. Then we have FSTI and STIF, to which I belong. We are basically the facilitators. We are the catalyst. We, facilitate researchers in conceiving the research, we help them so that they can hasten various processes. So we facilitate them. And we have MIT Directorate of Science and Innovation and STIF, Dr. Silva Murthy. We connect people to various national, international research agencies, industry, and other government and non-government agencies. Honorable Founder President has got one thing. He says that success by compulsion. So from time to time, he launches various missions. As Isha said, today's meeting is part of Mission Hydrogen, green hydrogen. So like mission outcome, he says whatsoever we do, there has to be some tangible outcome. They say that what gets measured gets done, that kind of a concept. And there is an independent directorate for that. And their job is to monitor and to evaluate the outcome of each and every activity which is taking place in MIT education. Then Mission Connect, connecting to various industries and agencies. Mission Space was launched last year when the Chandrayaan 3 successfully landed on a southern pole of moon. And then he had given the challenge to all the faculty that I want MIT should be number one partner with ISRO in space science. And after that, a lot of work has been done. We signed MOU with ISRO and we are pushing his mission. So all the missions which he announces, I think that had been a very, very good concept and he wants to further strengthen it. As I said, quality human resource, we have, many Nobel laureates to which we have connect. When they visit us, visiting this part of the globe, we invite them, we connect them for seminars, for joint research, joint PhD, and any or every way by which we can get, advantage of their association. And we also have many stalwarts of Indian origin. We have B.N. Malik, who is a Shanti Sarup Bhatnagar Awardee, B.C. Das, who is who has expertise in HPV, and he's said that he is father of HPV. And Dr. Rajendra Prasad, Dr. Silvamurthy is sitting here, and many fellows. I'll dwell on that. One of the signature activities which MIT has, I would like to draw your attention. The researchers after PhD, lot of people go abroad in Europe and US to do their postdoctoral fellowship. And they are very good people. And when they want to come back, we want them to come back. So Government of India, facilitates their coming back through many scholarships or many fellowships. Two main are Ramalinga Swami Fellowship and Ramanujan Fellowship. And they have to choose their place of work. So today I can share with with a lot of proud that MIT hosts the largest number of these fellows in this country. Largest number of fellows. And in this hydrogen mission, we have two Ramanujan fellows. Really. Uttam Gupta and Harishan. So, that has worked. And it gives us a lot of confidence and proud because they select MIT. So it means there must be some worth. That's why they are coming. And once they finish their fellowship, we do not let them go. We give them faculty position. And now about 12 such people are our faculty working, even at the level of professors. They have their independent group and completing or pursuing their research missions. I think infrastructure you have seen. I'll just go through quickly. I think we have sufficiently good infrastructure to carry out either agriculture or botanical research or animal research or physical sciences, material research or sensor research, and we leverage our facilities, combining, synergizing the facilities available in various campuses. Because we have 11 campuses in Haryana, in Rajasthan. So the facilities which are available there, we combine all these facilities. I think I'll just go through quickly. And recently, the promoters have established the MIT Center for Artificial Intelligence, where they have created 10 petaflop computing facility, and which is a common facility which is used by all researchers either from management science, social science, biological science, and they plan to enhance it. And this facility is headed by Dr. Datta, who is expert in AI. Coming to the research, now I'll just quickly wind it up. These are the main priority research areas on which we work, right from computation biology, genome engineering. Translational research is being given a lot of emphasis because whatsoever we do, it should see the light of the day. So that what we say that we are very much concerned about the one term known as valley of death. So we want to bridge the valley of death. Means valley of death is when science does not go beyond lab to the user. And recently I said green hydrogen and material science, space science, artificial intelligence. Now, I think I will not take much time. I'll just go through the titles only. That we have a huge group in cancer research, and where we pursue all the aspects of cancer, right from understanding the pathophysiology, diagnosis, finding new targets, finding new biomarkers, or monitoring the prognosis, etc. And we, while doing so, we use all molecular biology techniques or develop various in vitro models for that. We also have a neuroscience big group where they emphasize on developmental neuroscience. Agriculture biotechnology, it's also a huge group where they take care of all the aspects, right from soil health, plant health, environmental health, developing disease resistant plants, enhancing the productivity or fortification of the crop. Environmental research, we are very much concerned about that, and we have a NASA Space Monitoring Center station in MIT campus where they monitor the environment, and this project is in turn in collaboration with IIT. I think I have already conveyed that. We have got a defense technology, and MIT University offers the MTech in defense technology. It is one of the unique courses which is being offered under the mentorship of DRDO, and DRDO has funded a lot of projects to MIT in this regard. And one project I want to highlight is nuclear security state, and this project is funded by DATRA, Defense Threat Reduction Agency of Department of Defense, USA. And this is in the Dr. Alpna's department, and they had given us the grant of $1 million. Yeah. And we have got a MIT Dubai satellite ground station in Dubai, where they download a lot of data and which is analyzed to monitor environment and other aspects. Space science and technology, as I said, they recently launched mission. Our Mumbai campus, MIT University Mumbai, they expertise in astrobiology, and I am happy to share with you that they have sent the first biological payload in ISRO's recently launched satellite, and that was a very proud moment for whole MIT family. And we also work on image processing, debris management, and also making our CubeSat, and which we shall be launching in future missions. I said this morning you visited this, and we have lot of incubatees, the incubatees who have graduated, residence incubate and virtual incubatees. I think they explained you in detail about all this. We have got a good startup ecosystem. We have more than 300 student startups, and now a lot of emphasis is being given to have the faculty startup. And now the policy, faculty startup policy is in place to facilitate, for faculty to start their own startups. Now I have said all this, but there is a barometer of research barometer. Then where do we stand on that? What we have done? We have more than 36,000 publications in accredited or Scopus journals, more than 900 books. We have filed more than 2,310 patents. And after that, more than 415 patents have been awarded. 35 technologies have been transferred by Dr. Meenakshi Kanojia through her directorate, and many of the products from these technologies are available in market. And overall index, Dr. Selvamurthy sir, if I am right, it is 169 if the number is correct. H index is 169. This is the list of the technologies which have been transferred, and we have been amply recognized by various agencies on our IPR portfolio. We got recognized in 2020 with a National Intellectual Property Award, and this award was given by none other than Mr. Piyush Goyal, who is still the Commerce Minister. We also got the CIA Industrial Intellectual Award in 2023. We also got the Questel Excellence Award in 2022, and recently, recently we have got another award in 2024 by CII. This is the last slide. So MIT is not only in education and research. They have a lot of concern about the society. So they reach to the society through various foundations and focus on education of the underprivileged, women empowerment, livelihood, caring for the environment, research and impact evaluation studies, because there are two foundations, Amitasha and Atulasha, and they take care of the society. I think that's what I wanted to say. And once again, thank you very much. Now, I think we will play a small film on activities in space science by MIT.
Over the last decade, under the visionary leadership of Dr. Ashok K. Chauhan, Founder-President, Amity Education Group of Universities and institutions have made path-breaking research and academic achievements in the field of space, science and technology. Driven by the vision of Founder-President, Chancellors, Dr. Atul Chauhan and Dr. Asim Chauhan, led the research and development endeavors in space, science and technology, significantly contributing to India's space mission. Amity's advanced research infrastructure includes the Amity Institute of Space, Science and Technology, Amity Institute of Aerospace Engineering, Amity Institute of Geoinformatics and Remote Sensing. Amity Center for Excellence in Astrobiology has undertaken research to study the first biological payload in the form of callus of a vegetable plant is being sent to evaluate the plant growth in space environment. The Center for Ionosphere Studies was created with support from ISRO to study the equatorial ionization anomaly CREST. An Amity Center for Artificial Intelligence, in addition to Amity School of Engineering and Technology, provides high-speed processing for machine learning, deep learning and data science, supporting space data analytics. These institutes, while churning out skilled, competent workforce in space sector, are focused on the research and innovation. AI-based ship detection with optical imagery strengthens maritime security and surveillance, while SAR image processing identifies unlit dark vessels. Mars Analog Station at Ladakh tests extremophiles in Mars-like conditions. The Earth and Space Exploration Program, ESEP, was jointly hosted by Amity University, Mumbai and Cosmic Adventure Private Limited in Leh, Ladakh to simulate Martian environment and understand the human behavior in such challenging environment. Amity University has expanded internationally, advancing space research, and at Amity University, Dubai, Dr. Atul Chauhan had established a satellite ground station, enabling students to receive valuable data from satellites, particularly with the objective to predict climatic conditions and support UAE's Environment Vision 2030. Under the visionary leadership of Dr. Mrs. Amita Chauhan, Chairperson, Amity International Schools secured first place at NASA's prestigious International Space Settlement Design Competition, showcasing their excellence and innovation on the global stage consecutively for the last 5 years. Amion, The preparatory schools led by Mrs. Sapna Chauhan is kindling and igniting the passion for space science even among the toddlers. Guided and supported by Dr. S. Somnath ji, Amity University has deepened its collaborative partnership with ISRO through numerous impactful engagements.
I know that Amity University has been really a pioneering place where research and development, research and innovation go hand in hand with education.
Dr. S. Somnath visited Amity University, Bangalore to inaugurate the ISRO Amity Group Joint Workshop hosted by Amity University. The workshop highlighted critical themes including artificial intelligence, data analytics and astrobiology. During the collaboration, Amity leaders also visited ISRO's Bangalore facility, strengthening collaborative efforts in space research.
This is the program that we envisioned when I had opportunity to visit you at Mumbai. I'm really happy that we are able to have this workshop being conducted.
Amity University, in collaboration with InSpace, recently held a joint workshop on space science and technology for researchers across the Delhi NCR region. Hosted at Amity University, Noida, the workshop attracted over 500 young participants. Amity actively participated in ISRO-led training programs and workshops and served as knowledge partner for the Indian Space Conclave and National Space Day 2024 in association with the Indian Space Association and ISRO. Guided by Honorable Minister of Science and Technology Dr. Jitendra Singh and support from ISRO Chief Dr. Somnath ji, Amity witnessed the visit of eminent space leaders from various space agencies like ISRO, InSpace, Indian Space Association, National Remote Sensing Center, and RRSC North, etc. And under their guidance, Amity is advancing its journey toward research excellence.
The founder president of the Amity Group, Professor Ashok Chauhan, who is not only a pioneering academician in his own right, but has carried the tradition of Indian education across the globe.
As we continue to explore the vast frontiers of space science and technology, Honorable Founder President has launched the Amity Space Mission, under which we are committed towards innovation, collaboration and excellence, and emerging as a major contributor for India's space aspirations.
I feel obliged to me that, as Dr. Salwamurthy told, the most important partner in your public-private partnership mission, and we will leave no stone unturned.
Firstly, thank you, Singh sir. I'm sure that your presentation has provided deep insights about the Amity's commitment to academic excellence, innovation, research, and collaborative efforts. The Amity Space Mission video highlighted the Amity Education Group's dedication to pioneering advancement in space exploration. And the same spirit of innovation propels our efforts in energy sector, particularly through Amity Hydrogen Mission. Now, may I request Dr. Sunita Ratan, Dean Faculty of Science and Technology, Director, Amity Institute of Applied Sciences, to present the details about Amity University's contribution to the energy sector, followed by the remarks of Dr. V.K. Jain, sir.
Thank you, Isha. So, good afternoon. after visiting the Amity University, and you've got the good glimpse of Amity University, I'm bringing you back to the energy sector, that's the hydrogen sector. So I would be, first of all, I would also like to extend my warm welcome to Mr. Aron Govil, Chairman, and Mr. Alok Govil and Mr. Debashish Banerjee, to give us the time so that we all get encouraged and motivated, because the scientists, they only need the motivation and we can do lot. So when we say that Amity in energy sector, Amity is not only working in hydrogen sector. When we say energy sector, it's a plethora of activities where we really want to join hands with the world challenges for energy sector. And we are working in climate change and environmental sustainability. We are working with Namami Gange project in India, where we are joining hands with the government organizations to take part in clean Ganga projects. And similarly, we have got our partnership is also with India Meteorological Department. We are also working for forecasting models, etc. Then we are also working along with the National Disaster Management for climate related activities. And I'm very proud to say that during these activities, we've contributed around 1,805 publications, which have been cited more than 18,000 times. So this is our contribution to the energy sector, Amity's contribution to the energy sectors. First of all, and when it comes to the energy sector, we have some very good established institutions which are only directed towards the research in energy. And one is Amity Institute of Renewable and Alternative Energy under Dr. V.K. Jain. And the broad area of this institute is to generate trained manpower for national and international industrial and academic organizations in the areas of alternative and renewable energy, and hydrogen mission is one of them. So these are some of the areas they are working on: electric power transmission, secondary batteries, microbial fuel cells, electric potential, electric inverters, cellulose, biofuels, electricity, building air conditioning, ventilation, proton exchange membranes, and gasification. Whatever we can do to address the challenges of energy is being done at Amity University by different scientists. So, as Dr. Singh has already said, that we've got number of Ramalingam and Ramanujan fellows, and I'm very proud to say for this hydrogen or the energy sector mission, these are the Ramanujan fellow and Ramalingam Swami fellows, which are working in this area only energy area, whether it is hydrogen or whether it is renewable energy. So they all are working, and some of them are sitting here also. So, and these are some of the projects which are funded by the different organizations, government organizations, to work in this sector. So we have been working on these projects only. Now let's come to the more specific area for which we are here: research towards hydrogen value chain. When we say research towards hydrogen value chain, we have to deal with the production, we have to deal with the storage, and we have to deal with the utilization. When it comes to the production, we have, again, as Dr. Singh has rightly said, that whatever we take it in the form of mission. So this is the hydrogen mission, where all the institutions of the Amity, they have joined hands, and all the institutions, for example, whether it is Amity School of Engineering and Technology, Haryana, whether it is Amity Institute of Advanced Studies at AUP, ARAE, Applied Sciences, Engineering and Technology at AUP, then Mumbai, all have joined hands. We have picked up all the scientists who are doing research in hydrogen, and now they are collaboratively doing something so that some worthwhile research or some worthwhile comes out. So this is how we have collaborated, and we have made the cluster. When we say, I think most of the facilities you have already seen, and some of the facilities which you have not seen, I'll be elaborating on that. For example, you have visited Amity Institute of Renewable and Alternative Energy, which is guided by Dr. V.K. Jain. And he has shown you the photocatalytic water splitting. I think you have seen the setup where they are just using the photocatalyst for water splitting without any usage of energy, and they will be scaling it up. Then green hydrogen using a solar photovoltaic. I think this was shown to you here also, and then in some other organization, that the nanotechnology also. So number of people are working on these type of technologies also, where also we are minimizing the use of electricity so that the worthwhile value or economically viable product can be can be there for hydrogen production. And this is one green hydrogen from wastewater, again a very, very ambitious project where we can see that Dr. V.K. Jain told you that you can clean the water and then generate the electricity, which electricity would be used for electrolyzing water to get hydrogen and oxygen. So these are the three projects which are running at Dr. V.K. Jain's department. You also visited Amity Institute of Applied Sciences, where also we are working for production, storage, and utilization. Dr. Harish is there. He is working towards all the three goals, whether it is production using photocatalyst, electrocatalyst, and methane pyrolysis is he's using for production, and storage and transport, again metal hydrides, hydrogen resistant steel alloy, and liquid organic hydrogen carriers we are using. And for utilization, most probably if we get very good hydrogen, the yield is good, economically viable, then we'll be using it for iron ore reduction and for hydrogen fuel cell. So this is the plethora. And then our two scientists, Dr. Manoj Rola and Dr. Atanu, they are also, I think they have shown you that they are also working on photovoltaics only, and photocatalysts only, and they are using different materials. There was a question from Dr. Aron that what is, different people are doing different photocatalytic activity. The main problem is that the different photocatalysts have been developed depending upon different materials, because we don't know which one will give me the best. So this is the activity which is parallelly going in 2 or 3 departments, which we are using 2D nanostructures, then they are using metal sulfides, metal oxides. So these are the different photocatalysts are being prepared by our group. Similarly, you can see this is the video which is showing that how the photocatalyst is used for the generation of hydrogen and how very good yield hydrogen is being produced. So that is it. Similarly, one of our colleague, Dr. Arindam Modak, he is using conjugated polymers for the production of hydrogen. So similarly, again, this is wastewater treatment. Dr. Jain was using the industrial wastewater, whereas Dr. Anandam is using wastewater treatment. He is using the water where urea is there. So urea oxidation to hydrogen from wastewater. So that is again very, because urea is there when you like in many of the areas of Punjab and all, you can see in the water, it comes because its use is very much rampant. So that is what he is aiming at. Similarly, we are also making polymer electrolyte membranes for water electrolysis. This is my group which is making, and I've already told that we are not working on PEMs, which are already there, proton exchange membranes, because they are very, very expensive. So we want to reduce the cost. So therefore, instead of proton exchange membranes, we are going for anion exchange membranes. So that if anion exchange membrane is there, then we need not to use any platinum catalyst. We have to use nickel only, and that will reduce the cost, which is again one of the challenges of hydrogen production or hydrogen utilization. Similarly, when we talk of Amity University, Mumbai, this you have not visited, so I'll have included this. They are working on hydrogen storage. Dr. Amol K. Kamble, he is working on this. And hydrogen storage, as somebody has also briefed during our meeting, that it can be physical based or it can be material based. When it is physical based, we can use for compressed gas or cryo-compressed gases or liquid hydrogen. And when it is material based, then there are certain materials which absorb this hydrogen, and through that process, they will allow this hydrogen to release. So this is a sort of storage, which is the chemical storage. So Dr. Kumble is working on chemical storage, and he is using the materials which are metal hydrides. So metals will be incorporated with hydrogen, and through some mechanism, whether heat or so this will be released as and when is required. So metal hydrides work is done, and he has also optimized a heat transfer system for that. The whole scale is he's giving this scaling diagram where how he can be using this heat transfer system along with the metal hydrides and how the hydrogen is produced. Similarly, when we come to Amity Institute of Nanotechnology, Sumant is there, and I think you have visited it, and he has shown that if we want to address the challenges, we have to have the conversion efficiency of 10% with the current density 10 to 15 milliamperes per centimeter square, and which the material durability should be 2000 hours. And he has also shown that he has developed this solar driven electrolyzer, and he's working on it so that he can upscale the technology, and he can address the challenges which are there. So he has filed a number of patents, and these are the expected outcomes which have been discussed during a visit to nanotechnology. Then Amity Institute of Click Chemistry, which we also visited, where we have seen that how the hydrogen production is being taken by enhanced current density paired electrolysis. So these are the systems which we have already seen, that how paired cathode anodic reaction are helping us to produce the hydrogen. Then Amity Institute of Nanotechnology, Amity University, Haryana is also working on the production of hydrogen, where Professor Atul Thakur, Director, Amity Institute of Nanotechnology, Amity University, is working on this. I think Professor Atul Thakur is online, and he's working on hydrogen generation as well as hydrogen gas sensing, both. Right, so he is also working. For generation, he's using hydroelectric cell. I'm not going into the details because we have visited number of labs and we know how it is working. So he is working for these using different metal oxide based hydroelectric cells. He's producing these metal oxide based catalyst for that hydroelectric cell, and this is how he has been able to generate 0.9 volt EMF when only few drops of water are sprayed on the cell. So this is the preliminary experiment, and this has to be scaled up. So it plays. And the next topic they are working on is the hydrogen gas sensing, and they have prepared a prototype of hydrogen gas sensor, and they have patented the technology and have published the results. Then Amity School of Engineering and Technology, Department of Mechanical and Automation, we have already seen the hydrogen hybrid car, where they are mixing the hydrogen with the CNG and they are trying their best. And they are also using high calorific value natural gas using photosensitized dissociation. I think Dr. Basant Kumar Sikarwar has explained this in detail. So that's all. Thank you. So this is all the scientists who are working, and we look forward that some of these technologies will be scaled up to the commercial level. Thank you.
Thank you so much, ma'am, for sharing the insights about Amity's achievement and commitment to sustainable advancements. Ducon is a global leader in environmental control, material handling, and industrial engineering solution. Now it's time to dive deep into its innovative technologies and impact across industries. Let's go through the video shared by the Ducon, and then we can have the discussion.
Simple, yet intricate. In a world of contradictions, creativity has many forms, yet one source, challenge. A place where magnificent creations come alive. A place where you pause and we begin. Your partner in consistently challenging conventions to create a better world. Ducon Infra Technologies Limited. Consistency in performance. Established in 2005, Ducon Infra Technologies Limited is a pioneer in air quality control systems focused on ceaselessly contributing to nation's transition to clean energy, and a leading market player in dry bulk powder material handling systems in India, firmly rooted in the global Ducon group. With more than 8 decades of experience, ours is a legacy of engineering excellence that provides advanced engineering solutions. Adhering to our motto of consistency in performance, Ducon has successfully executed projects on pan-India basis over the last 2 decades, catapulting us to becoming leaders in the domain with strong emphasis on project management, time adherence, budgeted cost, and expanding existing relations. Our relentless commitment to these fundamental values has led us to consistently serve various core sectors of power, oil and gas, steel and metal, chemical and pharmaceuticals, pulp and paper, cement and fertilizer. Through proven technologies, expert manufacturing, and on-time completion, we have earned the trust of some of the major names in the industry. In its journey of excellence, Ducon Infra Technologies has defined itself as an industry leader that has set the path for many firsts. Through its robust outlook towards growth and challenging status quo, Ducon has had successful presence at trade shows, industry events, and has been a recipient of many recognitions. The legacy of Ducon is built on its unrivaled innovations and technologies for infrastructure projects where our core offerings are deployed. With specific thrust on FGD systems, we have an entire gamut of technologies comprising of dry, semi-dry, and wet FGD systems. This remarkable journey has led us to installing FGD systems in power plants, generating over 50,000 megawatts of power. The material handling system packages at Ducon are technologically advanced due to the process expertise of our talented engineers who consistently provide economically feasible solutions to our clients. Pipe conveyor systems, trough conveyor systems, rail wagon loading and unloading systems, and custom engineering solutions. Ducon's fundamental strength lies in conceptualizing, executing, and delivering packages on engineering, procurement, and construction, and lump sum turnkey bases of diverse scale and complexity. The safety of our people is paramount at Ducon. We are committed to follow stringent health, safety, and environment norms to ensure their well-being. We thrive on robust strength of capable engineers, dedicated workforce, and an inclusive work culture that keeps social equality and women empowerment at its forefront. The heart of Ducon Infra Technologies lies in its consistent innovation. Our dedicated R&D cell for utilization of hydrofuels research is focusing on green hydrogen, a crucial enabler of global transition to sustainable energy.
At Ducon Infra Technologies, we recognize that overcoming the global climate issues is critical to our planet's future. It is time for industries and power plants to realize the negative impact of toxic emissions to the atmosphere. At Ducon, we have executed over 30,000 global installations of air pollution control systems and have amassed an exceptional track record of successful installations, achieving significant reductions in hazardous gas emissions. With growing awareness towards cleaner energy and increased regulations from governments, we expect to grow exponentially. At Ducon, successfully executed major turnkey projects across the world to clients' complete satisfaction.
Ducon stands tall with a vision to develop innovative technologies and strong partnerships, powering sustainable future. Ducon Infra Technologies, consistency in performance.
Oh yeah, yes, yes. It's We the logo is like how the dirty gases they are black flue gases. Excuse me, I've just caught something during this trip here, but hopefully. And then we deal in technologies. Obviously, main focus is dirty gases become clean, and I mean I can talk in general. This was more focused on what we are doing in India. This video, we set operations in 2005, and we transferred a lot of the technologies But the original Ducon is started in 1938, actually by two Germans, and and then we took over in the 90s the company, and we have grown the company into a global entity. Uh, I mean, to give you an idea, there is probably not a Fortune 500 company which has not bought or done business with Ducon in US. You cannot find a name. You can look at General Motors, Dow Chemical, DuPont, Monsanto, any power plant. I mean, literally every single company over these years, decades, Ducon has been in business. We have successfully done work for them, solved their problems, and done an installation for them all across US. And Ducon over the years, we have had licensees around the world. So in Australia, in South Africa, Germany, England, and in South America. So through licensees, we have installations. Our oldest licensee is in Japan. They have been a licensee for last 40, 50 years. So by licensees, they license all our technology because the equipment we make is large equipment. We are not making some small items like this, which can be made in a factory, and then you ship it out and sell it. What we do is we actually, all our projects and work, as you saw, is done at site. We have crews, people who actually make the equipment. Some of the items are shipped. Some of the proprietary items are made at our, crucial shops and fabricators. So it's a complete assembly, as if you can assume like you're building a house. You have house being built, then a lot of stuff comes in, and various fixtures are put in, and then you have a complete facility. It's like this is what we do. We do a portion in a power plant. They have the boiler island, then they have air pollution island, the heat exchanger. So we supply a lot of those technologies for various in refineries. When one of the technologies we provide is when you crack the crude oil, when you're making gasoline and other things, it's done at very high temperature, and you need a platinum-based catalyst for that. And what happens is when you combust, you're burning it, all that catalyst also then goes out with the burnt gas. Now that's a very expensive catalyst. So in the 1950s and all that, Ducon worked with some of the refineries, oil companies, Standard Oil and all that, and we developed a technology, cyclone technology, which goes inside the combustion reactor, operating at 2000 degrees Fahrenheit, and it cleans the gas and recovers the platinum catalyst, which can be reused in the system. So that's a very high efficiency system which operates for years, 10, 15-year lifetime, and in very rugged environment. So it requires considerable amount of engineering skills, process skills to develop these technologies. So over the years, we have done a lot of research, and we have developed our own technologies. Plus, we have also bought and acquired other companies, just like it is done in the West. And then we have a huge range of companies and technologies in our wing. Not only are industrial, we also got into artificial intelligence, virtual reality, because when my younger son joined the company, he said, "Dad, you do such a boring industrial stuff. You should be in very cutting edge technologies and all that." So he allowed us to diversify. We do smart cities, these everywhere now, as you know, with driverless cars coming and all that. The cameras, you think we have cameras, we're going to have multitude. So driverless cars coming. So cities are going to be smart cities with software for recognizing. It's going to be, the whole world is changing so much. And as we've seen in our lifetime, how things were like from US, you would book a call through an operator. It'll take 2 days to get a call. Then we used to have beeper. Then we got a small phone. Now we literally live on our phone. So how we are changing, we've seen that in last 20, 30 years. Next 20 years are going to be even more things like with what's happening with AI, in the energy, and all these AI systems require energy. And there's a big demand for energy. So it's important that we also have cheaper and cleaner sources of energy. And that's where hydrogen comes in also. And we have a lot of challenges facing that, how it becomes commercially usable and acceptable and economical. So in that regard, when I said earlier, we have done a lot of research over the years at Ducon. We patented a lot of technologies, and we continue to do that. So for the Indian market also, we are keen to work, and that's when this opportunity came with working with Amity, and we were very excited because we want to work and develop, and that's what gives the industry an edge. Look at all the technologies which are in the bench scale and all that, and see which are promising, and even work on some new concept based on what we see in the industry and what we are seeing, and we have some ideas. And we want to collaborate with bright minds. I mean, frankly, I've never been in the company of so many doctors in one room, and it's very impressive and very humbling to see. So all of you here are such smart and intelligent people, and I feel it's great because you're what the company that you keep, and I look forward to that we can form a very good, cooperation, which is mutually beneficial for both parties. And I have seen over the years, we have always been in the forefront of technologies. We've always have, just now we supplied, when you convey material, we have supplied one of the longest, from one point to another, 2 kilometers long pipe conveyor. So all these things require, as you see in so many areas you're involved, new concepts, new technologies. But in the industry, it's important that what we give them is reliable, proven, because the power plants, they have online efficient, availability of 99.9%. Something cannot go down. Plus, everybody wants very cheap, solution, economically viable solutions. You look at all these groups, whether it's Reliance, Adani, Vedanta, they literally, they are also working themselves. So we have to work on getting the most advanced technology for the lowest cost. That's how we work, and that's what we hope to accomplish, that we can do that in forming a partnership that we do, because I feel there are a lot of bright minds here, and based on what I see, it's very, very impressive. I'm very impressed with the founder, Dr. Chauhan. I mean, what he has accomplished in such a short time. I have seen universities in the US, it takes them generations and generations to reach what he has been able to do in just 25 years. It's really commendable. It's really, really, and we are very excited and fortunate to be here today. And I appreciate all the welcome and all the, we have received. And Dr. Murthy, we've had so many meetings before, and we hope that we can continue this forward. Yes.
Before moving,
That's a great message, Govilji. I think we are very impressed by what you presented and your vision. So certainly Amity will be very, very delighted to be a partner in your endeavors, as well as we would like to have you as a partner in our endeavors. So it will be mutual. So we will grow together, academia and industry together. Thank you.
so before moving ahead, we would like to listen to Alok Govil, sir. So your remarks, please.
I think Devashri can provide more details. And I think, as Aron just mentioned, Ducon is a pioneer company. And we're all very proud for the accomplishments the company has made, and looking forward to a brighter future with the new technology and new tie-ups and partnerships. I think that's where the future lies. So I look forward to be part of that.
So now may I request Mr. Debashish Banerjee to give the proposal presentation mentioning the collaboration between Amity and Ducon.
Okay, thank you all. I'll just quickly go, I'll skip some slides because it's already been discussed by Mr. Govil. So as he mentioned that, we have been operational for the last 8 decades, and we have all proven our technology in almost everywhere in the world. And we are almost in all the sectors, from air pollution control to metal handling to waste water to waste incineration. Now we have started 3 new verticals. One is aerospace, second is green hydrogen, and the third is towards nuclear. So the topic today, the main focus is towards the green hydrogen. So I'll be talking more about that. And these are already covered by Mr. Govil. But just to give you an idea, in almost every country, we have our presence and footfall. And we have done several projects in almost all the countries. And obviously, we had collaborated with a lot of companies for the successful completion of the project. Okay. Yeah.
Just at least sit for 10 seconds on each slide so people get to see it. Otherwise, it's like from the beginning, you can do that. Yes.
Okay.
Yeah, go back. Yeah. Actually, I think we have time, right? Yeah.
Okay. Yeah.
Yeah. So this way, at least
You want to learn more about
yeah. So let's go back from the
beginning.
Okay. Okay. So I thought we are already having questions.
You can also say something on each point.
Yeah, you can mention when when it's hydrogen, I will take over. Okay.
So as you can see, these are all the pollution, environmental control. We are one of the leaders and pioneers. Literally, there are a lot of technology because every industry has different kind of pollutions. And what happens is in US, the regulations are also very, very strict. I mean, in some countries here, I mean, you can do 80% removal, you can do 90%, you can do 99%, you can do 99.5%, or you can do 99.9%. We have technologies, we can literally take the dirtiest gas and put it back into a surgical room, literally. Well, obviously, the cost is extremely exorbitantly high for that, but the technologies are there. So, chemical industry has its own problems. Pulp and paper industry has its own problem. Power utilities have their own issues. So, what differentiates Ducon is that being that we have been so old and we've been there, the continuously running company, we have some of the most advanced technologies and we understand all the problems faced by various industries. Okay. So, So obviously, this talks about our skills. Yeah. Go. Okay. Okay. Nuclear, we are tying up with a company because right now in the nuclear, we used to do like waste handling, encapsulation of nuclear low-level radioactive waste. Okay, we had technologies and projects we were working on where we encapsulate it and in concrete and all that. A lot of the waste in filtration that they use materials. We take fly ash and all that, and then incorporate an underground storage so it will not contaminate the water and all that. And
here I'll add to something that in the nuclear waste management, it's international consensus from all the countries that if you are dealing with nuclear waste, you have to dump it underground. So 500-meter underground, you create a repository. It can be of clay, it can be of bentonite, it can be of any material, but it has to give you the structural integrity. And then you put that thing, you encapsulate multiple barriers, and then you forget it. So that even if it mitigates the radioactivity of that particular radioactive system, it goes down drastically so that it doesn't impact our future generations. So based on that. So we were also thinking, because now there is sudden push of everything green. You hear the name green and everyone's like, okay, we have to dive into it. So India is also pushing into green hydrogen, nuclear and everything because to meet the demands of all our netizens. So the conventional nuclear reactors, it takes a lot of time. So nowadays, new technology that is coming in place, that is a small portable reactor, SMRs. So we were discussing more on those lines, how if we can deploy the SMRs in India, we can, manage the power supply and all. So in the nuclear, we were mostly working on.
There was a company that they said they could retrofit existing coal-fired boilers with a little bit of nuclear. There was a French company, was it?
Yeah.
Yeah. So, but then they are still, tie-up is still going on and all that. So we are looking forward to increase our footprint because that's what it is, getting away from fossil fuel. Yeah,
It's
yeah,
Bharat Small Modular, DSMR.
yeah.
Mm.
Well, I'll go one by one everything. Wastewater treatment, we work on the process industries and even in the power plants, they generate a lot of water that is generated. So we use filtration methods are there, coagulation, chemical treatment. We have vessels which have media inside them. Okay. And those are different, it's all custom designed systems for each application and where water is. So it can be because they have regulations, the pH, the dissolved oxygen, COD demand and all that. It has to be met before it can be discharged through the into the plant or wastewater like that. So those are the systems that we supply for that. Incineration, we do a lot of incineration is there for there's just certain amount of waste and chemicals that must be destroyed and all that. So we do waste incineration. We have different types. It's like all regenerative and recuperative thermal oxidizers. We provide them for destruction of, paints and stuff like that, waste materials and of that nature. Okay, so that's there. Emission monitoring is it's because of the EPA, you must monitor everything that goes to the stack in real time. Okay, it has to be reported, and if there's a gap, then there's a penalty on the facility. Any facility, whether it's a cement plant, is a chemical plant, is a power plant, any type, there is a boiler or combustion which has a stack, or so they must monitor all the emission. You monitor carbon dioxide, oxygen, flow, temperature, H2S, yes, all the gases have to be monitored. So that's it. That's also pretty, So all the instrumentation and that is required, we provide that. Material handling, we already talked about that. Okay. Aerospaces, we are working on. We've just actually got involved with a company on. This is we are getting in multiple ways. The one area we are already involved is
Here I can talk.
is this one is the low band. It's called the E band. Okay, which is right now I think there's a key car or some bands which are used right now. Yeah. Yeah, so this is a different band which has a bigger bandwidth, can be used for as more and more satellites are coming into the thing. There's going to be a shortage of that's like the highway for communicating between them, the satellites themselves, and then coming to the ground. So the low LEO orbit if that is there has the E band. So we are working with the company to get involved, and we actually just launched. They launched the first we have to establish a protocol there. So the last satellite that was launched by Elon Musk on I think it was on January 14th, it had our payload on it which had the E band to demonstrate that. Okay, so that was part of the, I think they had like 16 satellites on this. The one of them was also the company that we are working with. Their satellites were there. So it got launched successfully and it has established contact. So it's very complicated. It's done in stages. So the first aspect of this has been met. Okay. Then we are also looking at, go ahead.
So the second, yeah.
When you talk of wastewater or, this nuclear power, do you just consolidate and create the infrastructure, or you do R&D to improve the process or technology?
No. Okay. What we do is we provide. There are existing technologies, proven technologies. We are doing a project. We are solving the problem. They have a problem. They need to dispose. They cannot dispose the wastewater out. Okay, from the plant. So they need to install an equipment.
Okay. No. My submission is, it means you deploy the existing technologies.
Yes.
You are not into improving those technologies or developing new technologies.
No. We have already no person, no company would buy a brand new technology. First of all, they will not. Nobody will spend 100 crores or 50 crores. I'm telling for 45 years, and especially power plants. I'll give you an idea. When I was a young engineer working for a Danish company, Okay. For power plants, they have an online availability of such a high that it has to work all the time. They cannot afford an unproven technology at all. So we need to, if we want to deploy technology, even at a refinery or anywhere, we have to establish a pilot unit, take a slipstream, okay, from their wastewater or air, polluted air, or anywhere, and show to them that it is working, and it has to run for at least 6 months continuously. They will see what maintenance problem they're having, how much downtime they're having, and they will measure economics. Then they will make an investment for the full scale.
I have a very, vital point, because you are at such a situation where you are integrating many systems, subsystems, in system of the systems. Now, suppose you find that here is a point where I can improve it, or here is a point where I can deploy a better thing. So, to do that, would you mind engaging the academia, where research?
That's why we are here.
Yeah, that's what I'm saying. That those points you must be exploring.
No, we are continuously improving. The company has been in business since 1938, right? So we cannot be selling technology which was in 1950 now in 2025. So we have been doing R&D work. In the old times, even the wastewater, they could discharge it with certain specification. They have been improved further. So you need better technology for that, right? So that same thing in air pollution, same thing in instrumentation. So everything is changing the requirements. So that's why we are here. We want to work with the academic institution to look at what innovative technologies are there, which can be taken to a bigger scale up, and we can then go to a higher scale and then determine the economics of those things, improve the economics also, and then commercialize them. And have the goal would be to have, let's say, some item, green hydrogen or whatever, to have a commercial scale plant, operating on something like that.
Yeah, so I was asking, do you do turnkey projects?
Yes, that's exactly what we do. Yeah.
Technologies at PRL5, and somewhere I've seen biofertilizer and pharmaceuticals also. Good morning, ma'am. And
So let's welcome our Vice Chancellor. Welcome, ma'am.
Oh, thank you. No, definitely. Like we were talking, we saw this photovoltaic hydrogen. I was discussing like carbon dioxide, which is a greenhouse gas, is a big problem. A lot of money is being spent to develop an economical solution, because you have 10-12% CO2 in the gases that come out of the stack of the power plants, which is in millions of normal cubic meter per hour. So there's a huge amount of that. So somebody is trying amines, they're trying all kinds of things. So another one technology is having some algae or microbes or some kind of an organism which can eat that and then just take care of CO2. So that type of technology we can, I think somebody said that you're working on something
yes,
similar. So we would want to look at that, and then we would make a bigger pilot unit. And if we feel good, then we will talk to one of our clients and we say, look, at our own cost, we want to show you that pilot unit. We'll take their stream, we will put this, and then once they are convinced, then we'll get an order for the whole project. And the kind of projects that we deal in is 300 crore, 400 crore single projects. Yes.
Mr. Jain, I have shown you this our system, this wastewater to generate electricity, simultaneously cleaning the water. Under the DST program, we approved that after generating the electricity, this water is coming to the level which is permissible by the government of India to put into the river. So this is a new technology, and from today we have shown that even we are generating hydrogen from this electricity. So what do you suggest how we should go on? Because it is just at the lab scale. We are not gone to this pilot plant or bigger scale.
No, I saw that, and I think this is a promising thing. So the next step would be to build a little bit slightly bigger. We identify the parameters that we need, the size and all that, and we will invest and make a little bigger size unit. Please, I think you want to say, yeah. And then demonstrate all the variables and see how much hydrogen we are generating, quantify that, how much water we are cleaning, because it has double benefit.
yes.
Okay, from that, and what are the electricity and whatever we are utilizing, and then we'll try to improve upon them. And when, because we know what's norm in the industry, and then once we see that it is on par based on the benefits, then we will go to a bigger uh, pilot scale unit after that. So it may take 2-3 years to do that.
Actually, this is a multi-purpose technology. So one of the application, as you have already seen, the wastewater treatment, electricity generation, hydrogen generation. So after, as sir has already said, that after cleaning the water, it matches the government parameters so that you can release the water for the irrigation purpose and all. Sir is also having a technology for the drinking water, for the purification of the drinking water, which is based on silver nanoparticles. So combining these two technologies, it will become a combo package for you. So you can consider these two technologies and combining them.
Thank you, Meenakshi. Let's listen to his presentation on the project itself, if it is okay.
So,
Yeah, please.
the second,
That is very. Yeah, we can do it during lunchtime.
okay.
Go ahead.
So the second aspect of aerospace that we are working on is okay. So it's propulsion and cryogenic technology. So in Germany, the partner that whom we are working on, we are already providing equipments for ESA, European Space Agency. So the last meeting which we had with ISRO director, it was very fruitful, and he was very impressed with the technology, the check valves, pressure regulator, BLDC motors, and everything, solenoid valves. So the only thing that he mentioned, and it was again the same Indian thing, that the technology is good, but the price point. So in order to match the price point to an Indian price point, we are thinking, to take the technology, mature it in-house in India, bring down the price, and then cater to the Indian market and even ISRO. So that was the second aspect of aerospace technology. So moving over to
Yeah, okay. So this is just why as name recognition. We've already covered the patents, continuously in operation, technology advanced system. Okay, the name recognition. I'll give you an example. Our name is so well known, Ducon. We get calls from companies. Oh, we have a Ducon equipment. It was installed in 1967. Now we need the exactly same thing. They don't even go anywhere else. They're so happy with our equipment, technology, and durability of the things. Massive amount of repeat customers in business, and same thing is happening in India as well. Whether it's Vedanta Group or IOCL or Nalco, Balco, Hindalco Group, everybody comes back to us. Go ahead, continue. Okay, we've covered this, yes. These are just details of the types of air pollution control equipment for different industries and different pollutant and all that. So we're not going to go into that. This is, again, very technical. This is a list of all the power plants that in all the countries that we have installations at. In China, we've done Czech Republic, Brazil, Indonesia, Serbia, Sudan, India. We just go back to them. See, in India, we have done business with Dahanu Power Plant in Reliance, 500 megawatt, Starlight. Shiri Power is there, Lanco in Udupi, 1100 megawatt. Tata Power, we had done work for them in Trombay station. So these are various projects in Saudi. We had done 750 megawatt in Jeddah. We had did work also. It's all over. Yep. These are all the work in United States. These are, U.S. has started environmental control and emission monitoring controls long before anyone else. In the 1970s, we started. So a lot of these projects are from 70s and 80s, and they still continue to operate. And, we are in very large scale equipment. I mean, these are massive equipment that we deal with. We also deal with small, but R&D, you have to start small and work your way up. And Larson and Toubro, we are just doing a project for them. L&T, Doosan, everybody knows a lot of these companies. Hyundai Heavy Industries from Korea, Samsung, these are all our customers. Jacobs Engineering, these are all the engineering companies. They are the ones who work with all the major clients and they design the equipment. So we have to work with them. If we have a new technology, we're going to have to go with Worley Parsons, Burns and McDonald's, Jacobs, and tell them that, look, you've been doing this thing for last 30 years using this. We have a proven technology. We want you to consider this now. Okay, so this is how then it will be spec'd in, and that's how it gets introduced, that equipment. Go ahead.
Okay.
Devash.
So now I'll talk more about the hydrogen. And before going towards hydrogen, we should also focus on what are the plans from the government side, because then we can dive deeper and into that particular bracket that we want to target. So in currently from the site program, and you people also know much about it because we recently wrote a proposal, we submitted a proposal to Ministry of New Renewable Energy. So out of the 17,490 crores, the financial incentives have been given to either you produce the hydrogen from electrolysis, or the main idea is to produce the green hydrogen. And we India, we have to be net carbon zero by 2070, and these are the mission outcomes that what the Indian government has planned. This thing is also very important in the last, that MNRE industrial cluster I want to mention, that where is the cursor, I don't know, is there a pointer or something like, okay, so this one. So in this, there are 2 green hydrogen hubs that the Indian government has planned to develop, and they have already allotted 400 crores for it. And again, it's same like center of excellence, but a different bracket. But we can also look into this aspect, how we can enter this bracket, and because the funds are also very good. And again, you have different waste to energy programs, also bioenergy, because in Amity you have different projects running on, so you can also focus in all these brackets that we can target. uh, Also important thing is that this year the budget that was just announced 2 days back, so they have significantly increased it. So earlier it was 21,000 crores, and now it's 10,000 more, so it's 31,000 crores. And then the increased allocation for green hydrogen, it's also been doubled from 300 crores to 600 crores. That's also a very good thing for us. And then again, a lot of push is happening towards the solar energy. And the good thing about us that we can capture this area, which is, I don't know why the cursor is going down. Yeah, this one. I would really like to have a pointer, but this one. A significant allocation of 2,000 crores have been designed for the development of green hydrogen towards linked with solar energy. So as you mentioned, that the solar thing, we can work together in this.
Like that, the technology that we are talking about.
Yeah, and we also saw in Dr. Suman's lab that he is also working closely towards this. Not only Dr. Suman, there are so many other, individuals that are working. So
We can, if we make a little bit of progress on our own on that, then we can approach them, correct?
definitely, yeah. So we are all open to like working closely and think about jointly doing an R&D on it, and then take the technology from there. We have to mature the technology, and before that R&D is important, as you all know. So okay, it's good that you have already started in a lab scale, but we can scale it up. If we can, you can prove us that we can mature this technology. Yeah, sure. So now we will also review it among ourselves, and then we have to. So we are not restricted. Ducon is not restricted itself only to one project. If Amity can prove us that there are different projects that can that have potential, Ducon can fund those projects and make them see the light of the day. Yeah.
Control and the laser module.
That's the point. Yes. Yes. वहाँ नहीं आ रहा है. But it is only in the wood, not in the.
I think you have to control and control it. Yes. Now you can see the pointer over there.
Okay. Okay. So great. So yeah, just I wanted to also mention about this budget because we have to also think in the lines what the government is planning. So yeah. Again, because we mentioned that there is a lot of focus on the solar thing, so they have the government has also announced lot of subsidies which can be good for people who are working with the solar panel. For example, if you see the second these thing, like They have provided subsidies on solar inverters, batteries, and mounting structure. For example, in Amity, if we are integrating the solar technology to produce hydrogen, again, we will get subsidies on the batteries, mounting structure. So again, the cost will go down. So we have to be also thinking on a business point of view that what technology that we can mature if it is aligning with the government schemes. Again, these all the, I think the technical people will know about it, like the raw materials, silver paste, sheets. Okay. So now I'll come with to what Ducon is doing. So we are into, okay, so we have to understand that if there is a push for hydrogen production, but eventually when you will produce a lot of hydrogen, okay, then you have to think about where do you want to store it or where do you want to transport it. So this is where we come. We have proven experience for hydrogen transport, and now we want to enter into hydrogen storage. So that's in storage. We want to partner with Amity because we have been told that there are a lot of upcoming technologies like LOHC, these different new storage technologies that we want to work with. But just to give us our expertise, we have a proven experience in solenoid valves, pressure regulators, check valves, relief valve, BLDC motor, fill and drain ways. We the company who is contacting us, they just have to give us the specifications that what is the operating temperature, what is the pressure they want to operate, and we can custom design it. So again, the idea is same. We are currently developing it in Germany, but then we want to do it in India to bring down the cost. And obviously, for Amity in for the center of excellence, we are also thinking that when we get that proposal, and I really hope we do, that when we have more hydrogen production, then we can also integrate it with this technology, transport and store, and create a whole hydrogen value chain around it, whole hydrogen ecosystem, so that we are not going to stop with only one proposal. We are going to keep on filing proposals and all.
These components are also useful in liquid propulsion rockets in space also, because they are looking for that right now. So we are also talking to ISRO and other companies, and this is all developing. It's all new. There are not that many players. So hydrogen is used also. They are using liquid propellant. Will be used because the atmosphere is the same over there. So in hydrogen as well in space, they have dual application. That's a separate. This is our thing that we are doing, but it will be used in any work we do in any items or equipment that we develop. They will require this component.
The very next step.
Yes.
So the only change in the aerospace as well as in hydrogen is that if you talk about liquid hydrogen, then cryogenics will take place, because then you have to go down very low temperature. So that's what is different here, because because we are visiting different international green hydrogen conferences. So then when we asked the question to the decision makers of the country, they said, and it was very clear, that if we are thinking of even exporting or importing hydrogen, it won't be using liquid hydrogen. It will be in a form of gaseous hydrogen. So then we asked that, can we use the existing pipelines, LNG pipelines, to transport the. Then again, because of the property of hydrogen, you cannot use the existing LNG pipelines. So then we thought, okay, we have to start something which people are not thinking as of now, but eventually you have to stumble upon this technology. You have to think about storage, you have to think about transport, and that is why we are tweaking our equipment to the hydrogen application. Yeah. And yeah, that's it basically. And in Ducon, as we and Mr. Govil has mentioned, you submit us. Yeah, you just submit us the projects that you feel that it has potential, and we will review it, and we are happy to fund that project to scale that technology to a much larger scale, and make that project see the light of the day. So yeah. And again, it should. If you're thinking about aerospace, also please let us know, because we just discussed with Sunita ma'am also that and she mentioned about the carbon thing. We are also interested in the carbon capture. So ma'am, we will sit again. We'll discuss more, because it's not that everything comes from an idea. If we can use part of that and create something new and integrate it, then I think that's a big win. So yeah, I would like to end that on this note, and we are happy to collaborate again and do let us know, and so that we can review, and we can, this is not the first meeting, so there will be several meetings lined up, and yeah, thank you.
As we had discussed, Dr. Silvamurthy and of course Dr. Shukla, that I think what the way would be that if we have a broad agreement on overall cooperation, like both parties, what we are getting, what you're getting, and what resources we are providing, and then for, let's say, if we select so many projects and the funding we will give, and we talked about maybe having some area which is a Ducon Amity research area, where we can do 3 or 4 or 5 projects that we select, and then we move forward. Then we can select in the later stages one by one, as Dr. Murthy we had discussed earlier, whether it's the photo project or it's whichever 3 projects, and then we come up, we wastewater, and then we decide what the budget will be, how much funding is required, what is the time frame in that individual one. But the overall scheme that how we are sharing, what we are sharing, and who owns what, that would be done in an overall MOU for all the projects, and then we can move forward and then and do that. I think that may be the, if we are in agreement, we can go forward, and we would, because there's so much going on, there's a lot of competition, it's better to move fast at good pace.
Thank you, Aron. I would also request Dr. B.K. Murthy, who has been interacting with them even on the online meetings later in the evening, just say your.
Thank you very much. See, what we have been discussing is that there are a lot of areas, fertile areas from your side and our side also. So what we can do is we identify these priority areas of these things, and we can have an overarching MOU converting with all these areas, covering all these areas. And for each sub area, we will take a specific targets, achievements, and where we are and where we have to reach within next 3 months, and what are the deliverables for you, and as well as what are the roles and responsibilities of each organization, and come out with a clear cut milestones. After 6 months, what we'll achieve, after 1 year, what we will achieve, and we can deliver it. Because we are, our researchers are more into a little bit of R&D type of thing. They will not satisfy if one POC is there. They wanted to keep on improving and then getting various other things.
Thank you.
But from an industry point of view, once a POC is there, how you want to sell it immediately, that is where you come into. So we need to marriage these two and then to bring out the technologies.
Thank you.
Also, one update I would like to say that in that, for the Center of Excellence proposal that we submitted, I'm happy that Mr. Govil had agreed a funding of equivalent to 2 CRs for the XPS thing that you had mentioned. So for okay, the way we see it is like, for COE we would commit this much allocation, and for the other thing, because we don't want to restrict to only that, we want to create the whole hydrogen value chain. So we want to even set up the storage and facility here, because we have to integrate it, production with the storage and transportation, so that if a person think like, where is hydrogen thing, who is operating directly, there should be one name clicking his mind: Amity versus Ducon, Amity and Ducon, ex Ducon. Whole value chain, you guys are producing, we guys are storing, and create an ecosystem around it. So yeah.
Thank you, Shivali.
Yeah. Yes, sir. Yeah.
That is a separate. That is separate.
That's a separate. Yeah.
It is separate.
Yeah, it is separate.
Yeah. Then that will be separate. Yeah.
Aron, just you were invited by Vice Chancellor specifically.
Thank you.
Because you are going to have a startup.
I'm really excited to be a part of this meeting. Thank you, ma'am, for inviting me. So I know hydrogen production and storage is equally important. We have been teaching to our students these topics, and when it comes for implementation, that really probably India is lacking right now, and we must jump into these things. So I would like to introduce myself here. Myself, Ranu Nayak. I'm a full-time professor at Amity Institute of Nanotechnology, and currently almost on the way of starting a venture under the umbrella of Amity University, and special guidance from our Vice Chancellor, ma'am,
and Murthy sir, and of course Selva Murthy sir. So my venture is mainly on wastewater remedial based on nanosorbent technology. Right now, I'm more focusing on oily effluents and hydrocarbon based pollutants. So I had a biotechnology ignition grant from BIRAC. So through that BIG grant, I am planning for this venture. We have already got some third party validation. BPCL had been our advisor. They have visited the campus and validated our technology. So right now, I think I'm at this stage to start up this venture with all my
Thank you.
all the blessings of
Our
Amity
blessings are with
Advisors.
you, Ranu. Actually, you sent the some sketch, the broad outline to Dr. Aron Goyalji, so that he may also like to partner with this your startup company and then handhold you, because they are in the exactly in this field, the waste management.
Will be because it has a lot of commercial applications. Oily waste is not only spills but anywhere else you can use that. So it's all depends on what is the novelty, how innovative it is, how what is different from the prior art, and yeah. Yeah, separate presentation, and we can definitely look at that when we look at separate, projects and all that. Yeah, exactly. That is very good. Okay. Yeah.
So
Yep.
we have basically put the ball in your court to propose us the projects, and then we can review it and see how we do with the funding.
Very good. So before
Thank you.
we give some concluding remarks and all, I would request Vice Chancellor Madam to say a few words. Then
Yeah, thank you very much. It was really indeed a pleasure meeting you in the morning in person. And today we have many things, and that's what the Amity is known for. Very dynamic environment. We had a new program which we have started today for the the advanced diploma in child counseling and all. We had a cybersecurity conference in our Lucknow campus, and then this meeting. And Honorable Founder President has given a mission to all of us to set up the Center of Excellence in Hydrogen Mission. And it was a long time back when Founder actually initiated research and innovation in this area. Dr. V.K. Jain has been the first person to work in this area, and then Dr. Sunita Ratan's institution also. But today, when we look at, we have the big group of scientists in the universities, Dr. Harish, Dr. Ekta, and many others who are focusing on this area. So we were able to, with your support and other industry partners, the university partners, we have submitted the proposal for this MNRE Center for Excellence. But that's one. But founder president's commitment is there that this is the future. The green energy, when we talk, the whole world needs it, and how the India can be the leader in this. When we were submitting this proposal earlier, it was for all the areas, right from the production to the storage to transport. But the MNRA said, no, you focus only on one area. So that's why we said, okay, we'll do for this center of excellence only production. But we need to work on all the areas. So I'm extremely thankful to you when you have said that you will be supporting for apart from the COE, that other projects also, because our scientists are working in this area, and the founder president said that collaborate, collaborate, and have the synergy which will bring the outcome. And because if really we have to make the India the hub, and I also make the India the Viksit Bharat is very important. We emphasize industry supported, industry led, I would say the industry supported and industry led research, because the scientists have a lot of ideas, but every idea is not that it will contribute to the industry. So therefore we need that vetting from the industry, where the industry is moving. what is going to be the future of the industry, in which area what problem they are facing, and where should be the university should have the focus for research and innovation. That also comes from the what are the government missions, because government also thinks from that angle. Okay, they allocate the budgets and all those things. So therefore, that today the industry academia collaboration is extremely important. And your visit today and seeing the presentation, I think that many areas of collaborations are there. Not only the space of hydrogen mission, the if you take the whole value chain from production to the ultimately to the distribution, okay, to the end user. But it's also has the other areas. Our honorable founder president has committed to Chairman ISRO when we were having the one of the conference, and that conference was also almost 12 years in series. We were doing the signal processing and integrated network when nobody was thinking about it, and that's what that and the chairman ISRO said. You know, the if anything has to be done in the space, signal processing is extremely important, and that's where the integrated network plays so important role. And at that time, Honorable Founder President has committed to him that Amity will be the biggest contributor in the research and innovation in the space area. And that's where many of the scientists and researchers are working, and we have developed the many clusters under the guidance of Dr. Silvamurthy ji, our president of research and innovation for whole Amity Education Group. So we'll look forward seeing your areas, your presentation. We will have our internal deliberation and see that which all the areas we can partner and put up our proposal for your consideration, because it is always that there has to be synergy between the two organizations. Then only the bigger outcomes will come, and because the continued interest will remain, and when there's a continued interest is there between the two organizations, outcome is also bound to come, and that's where we want to focus. So once again, very warm welcome at Amity University, and we look forward your guidance for the areas where you have the interest and where our scientists also have the interest, how we can work together and contribute to the industry and to the economy of the nation. Thank you.
Thank you. Thank you, Madam Vice Chancellor. First of all, let me express our gratitudes because I have been interacting with him almost now more than a month. Shefali has been organizing late evenings at 9 p.m., 10 p.m. Thank you, Shefali. She's a prime mover. Thank you so much. And also thanks Alok Goel ji, and also Vandana Goel ji is missing. We are missing her. She showed so much of enthusiasm to partner with Amity.
Because I'm so busy
Yes.
in so much stuff going on, and he said, "No, we want."
So please convey our love and affectionate regards to her as well. And also Dev, she's very dynamic R&D expert with you. So we can do many things. I had a word with founder president today, this morning, and he has conveyed that his dream is Amity also like in space. He wants to be in hydrogen mission as well, one of the biggest in the country, and then maybe at the global level over a period of time. And whatever he says, it is achieved. This is what we have seen today. You see today, in 20 years, if we can create so much of Amity universe. So now the next thing is thanks for becoming a consortium partner for our Center of Excellence. You have your the intent, letter of intent was very valuable to us to propose and hope that we'll be getting, irrespective of whether we get this Center of Excellence or not, we are going ahead with the collaboration. And then as you desired, then over a period of time, you will have a center here. Your center, industry center here in our campus, we will name it as your Ducon Center, Amity Ducon Research Center or something like that. We'll put that. Then the submission of joint projects, not only you fund the project here, but we can submit to funding agencies together, like some of them which you mentioned, Devshish, we'll do that. Then the next part, the last part will be that rigorous monitoring and push is required, reviews. So this is where Shefali is a great pusher. So please ensure there is a fortnightly review happening. Otherwise, no, after they go back, they become busy and we become busy. So keep that pressure on the system to perform and achieve the outcome from this collaboration. With this, again, all my brilliant faculties, you have done a great job, and he's quite impressed. He was just whispering into my ears. I'm so impressed. So thank you so much. Now I would request.
Thank you, Dr. Selvamurthy. So now, since I think much has been discussed, and you have yourself seen, all three of you, the capabilities and capacities of our scientists working specifically in the hydrogen sector. But I see that your industry is into many other subjects, many other fields where our scientists can collaborate and contribute. And as Debashish mentioned, that I think now is the time that we have to now work on the research proposal from our side. And as Shefali mentioned, that this is above and over and above the 2 crore, which I think you are committing to the Center of Excellence. I think, and a big thank to you. Whenever an industry I've seen in my past few decades of experience in government, industry showing such a great interest and enthusiasm in a university like us. And Dr. Selvamurthy was mentioning that several meetings have happened. I attended only one, and probably Shefali organized several meetings during the night time as well. And these kinds of an enthusiasm, this kind of an interest from an industry like you, you are a successful businessman, you're a successful industrialist yourself, showing this kind of an interest in MET University. For us, it's a pride for all of us. I think so. To conclude, there is a possibility, and a big possibility, of collaborating between our scientists. We will certainly work on this for future, project research proposals, and not only specific to the hydrogen, but other sectors as well. And as Dr. Selvamurthy also mentioned, that we would name it some kind of a center of excellence of this kind. And I am sure, sir, it's not that we will not get the center of excellence. We will get the center of excellence, because the proposal Shefali and her team has prepared is a big proposal. It's a great proposal. They have worked very hard. They worked very hard. And I must also confess that there are several industry partners in that particular proposal. So it's a very strong proposal. Dr. Uttam, Dr. Harish, and
Dr. Abhishek Verma.
and many others. Yeah. So they have partnered with the, and Debashish has rightly pointed out the government ambitions in the budget. It's a lot of ambitious budget, not only in the hydrogen sector, but other sectors also. And we have to align ourselves, our thinking processes. So with that, I would like to conclude. Thanks once again, all three of you. Thank you.
One
All the meetings 24 hours.
Yes, and we have ventured in preparing the Center of Excellence proposal as well as the other projects also.
So all good things should conclude with a dessert. So the icing on the cake is that for that whole excellence center of excellence and the research lab that we are going to set here, we are also going to take placements from MIT, the Ramanujan Fellow and all, who can work for the program.
So now Sir, thank you so much. And I'm so grateful. I'm so honored, Devashish. And we are so grateful for your kind support and insight during our MNRE CV proposal. And we have really worked hard with your kind support. Thank you so much, Arun sir, for your kind blessings throughout our journey during the MNRE proposal. And Vanda ma'am, she was always there during the night. And madam attended all the meetings. Ma'am gave all the inputs. And we are so grateful to you, sir, for your presence today in the Amity University. And we are looking forward to have a big collaboration in hydrogen sector. And yes, sir. Thank you so much. Thank you so much, Alok sir. Thank you so much, sir. Thank you so much, sir. Now I request all the Amity dignitaries to come forward and felicitate our guest. A huge round of applause for Mr. Arun Govil, sir. for Madam, sir. We are missing Madam.
Thank you so much. Thank you. Oh, definitely. Yes, yes, yes.
We would also like to felicitate Mr. Alok Govil ji. We also want to express our gratitude to Mr. Debashish for taking up this collaboration and bringing up to the level where we are today. Thank you so much, everyone, for the wonderful discussion today. Thank you.